Learn efficient pharmacology. Passage of drugs across the plasma membrane, part 3. Pharmacological relevance of simple diffusion and Henderson-Hasselbalch equation. L and B are two local anesthetic drugs. We usually administer local anesthetic drugs close to the nerves. They then enter the nerve by simple diffusion and block the nerve impulses. This blocks sensations, motor or autonomic functions in the region supplied by the nerve. Let's assume that L and B are weakly basic. L has a pKa of 7.8 and B of 8.1. The physiological pH we know is around 7.4. Now, do you remember the Henderson-Hasselbalch equation? The one we had used to estimate the ionized and unionized fractions of a drug. pKa minus pH is equal to log concentration of the protonated form divided by concentration of the unprotonated form. Since here we are discussing weak bases, the equation will be pKa minus pH is equal to log concentration of BH plus divided by concentration of B. When the physiological pH is stable at 7.4, as pKa increases, pKa minus pH will also increase. So if pKa minus pH increases, what fraction of the drug increases? Ionized or unionized? Ionized. Now answer this question. At physiological pH, which drug will be more ionized? L or B? The one with the higher pKa, that is, drug B. Since more unionized molecules are available for drug L, its rate of diffusion will be greater compared to that of B. Can you guess the effect? The onset of action of L is likely to be faster than that of B. Let's go one step further and see what happens in inflammation. In inflammation, we know the environment is acidic. Let's assume that the pH dropped from 7.4 to a more acidic 6.4. So for L, pKa minus pH will now be higher than before. That is, L will ionize to a greater extent. This decreases the amount of drug that can cross into the neuron. The same happens with drug B too. Since pKa minus pH is greater, the degree of ionization will be much greater than that at physiological pH. This is the reason why local anesthetics are less effective in regions of inflammation. Pause this video to read this before you proceed. This shows how a single unit change in pH affects the degree of ionization of a drug. So to summarize, we saw two scenarios where the pKa and pH affected drug action. In one scenario, drugs with different pKa were at the same pH. The result was faster onset of action of the less ionized drug. In the second, since there was only one drug, pKa remained the same, but pH decreased due to inflammation. The result was ineffectiveness of the drug due to increased ionization. Until now, we have seen how lipid-soluble molecules cross the plasma membrane by simple diffusion and how this is influenced by pKa of the drug and changes in pH of the environment. What about drug molecules that cannot cross by simple diffusion, like ions or large polar molecules? Wouldn't these molecules ever cross the membrane? We'll see this in the next video.